We're in section 9.2. Does anybody have any homework questions before we continue? Yes.
On 10.3, the question.
10.3?
Yeah.
Okay, so we'll wait till we get to the lesson on 10.3 to do the homework on 10.3, okay? So we'll need some formulas that we look at there. Any other questions? In section 9.2, we're looking at making data visible. So the goal today is to make sure we know how to make a histogram and a box and whisker graph. Either of those may prove helpful to you in a future class or just in your future job sometime, or when you're just trying to compare a vast collection of data yourself and figure out what's going on. So here's some examples of a histogram. Histograms keep track of the frequency of numbers of data. So you'll always see the vertical axis labeled as frequency on a histogram. And then you have bars. Here, for example, we have scores between 20 and 22 for exam scores. Now, as you make a histogram for whatever purpose, you'll have to decide, excuse me, what scale you'd like. Excuse me. So on the top, the scale is by 2s. On the bottom, the scale is by 5s. So you yourself would have to think about, what am I trying to show? What would be most useful to me? Now, if you look at this histogram, this is a histogram showing heights. They measured a particular student, one student, something like 100 times, but they never got the exact same height, not very often. So these heights are measured in hundredths. Because it is a height, though, and there is, there should be a how tall she is, there's most of the measurements in the middle. And that's what we call a normal bell curve. So this is what you would see as a normal bell curve for data that you would expect to be trying to measure one thing precisely. This particular histogram, on the other hand, doesn't have the peak in the middle like this one. This one has the peak on the right, so we call that skewed to the right. So you could have a histogram that has its peak in the middle, like a normal histogram, or you could have one skewed to the left, as this one is, or you can even have one that has two peaks. That's called bimodal. So here we have an example of a bimodal histogram. This histogram records the SAT scores for students when they were taken by, the SAT was taken by two groups of students, one in junior high and one in high school. So the group in high school has their cluster of grades around this peak, and the group in junior high has their cluster of grades around this peak. So that would be a bimodal distribution. Now you can study this idea of a normal curve very intensely. In fact, you can study it enough to figure out how much it varies. So even if you have a regular bell curve shape, your bell curve could be sharply contracted around the center, or it could be spread out. And that measure of how spread out the graph is called your variation. So a large, variation has the word vary in it. So when you're looking at your variation, you're seeing how much does the data vary from the center. How much does the data spread out? So this graph doesn't spread out very much. It's clustered tightly around the center, so that would have a small variation. Whereas this graph is spread out, so it varies greatly. The data points vary greatly from the center, and they're not all clustered around the middle. Well, you can spend a lot of time studying the bell curve, and if that's interesting to you, you can go on and read section 9.3 on your own. In the art class, we're just going to focus on section 9.2, figuring out how to make a histogram and a box and whisker plot. So let's start with a histogram. So as you make your histogram, you're going to keep track of the frequency, and that will be on the vertical axis. And then you'll keep your bars right next to each other. There will not be space between the bars. If you have space between your bars, instead of a histogram, you have a bar chart. Make sure you have a title and that you label the axes and title the axes. Also, the whole point of these graphs is to show where data is clustered. So you notice the scale is consistent from beginning to end. Now you might not include much past the beginning or much past the end as they did in these heights. It doesn't go off over here down to 6 feet 3 inches. It stays nearby. But you're not going to have spaces or gaps in between your scale. So here, for example, there's a big gap between the 20 to 25 and 40 to 45. We don't put like a little zigzag in there. We want to show the gap because the whole point is to show, well, look, there's something missing here. There weren't many scores here. And you can't see that if you put those little breaks in, okay? So the scales need to be consistent. So sometimes students break the graph and show that little zigzag to break it. Don't do that on these, okay? So these are the types of things that I'm looking for when you hand in your histogram on the quiz. Let's go ahead and make one. Let's make one for the prices of homes sold recently near Green Bay. So we have these prices. We've looked at these before. These were the ones that we saw in class on Friday. And we saw that rearranging them from lowest to highest helps to explain the data. Using the mean or the median helps to explain the data. Now we're going to explain the data using a histogram. To do that, you need to keep track of your bins. So your bins are how you're scaling the data. For example, on these quizzes, they had bins that were in units of 2, or in the bottom they had bins in units of 5. So decide on what bins you want to use. I'll just use 50,000 bins here. So from 0 to 50,000. And then when I have a house that sells for 50,000, I'll put it in the 0 to 50,000. But I'll label this one 50 to 100. But I myself will remember, okay, if I sell a house for 50,000, I'm going to put it in the lower bin. In fact, because of that, if you ever have to show your histogram to someone, bring your raw data with you so that you can check on these points. If someone says, well, I have, a house over here, why didn't you put it in there? And you can look at your data and say, oh, because I put it over here. So people want to know details sometimes, and you should have your data with you if you ever have to do this in real life. Now when I set up my bins, this is my work for myself, and so I can leave a blank here because there were no houses sold between 400,000 all the way up to the 669. So I can skip on my raw data here from 650 to 700 and leave a big blank. But I'm not going to do that on my actual drawing of my histogram. So let's see. Now we count how many houses fall in these categories. So 0 to 50, none. 50 to 100, 1, 2, 3, 4. 100 to 150, 6. 150 to 200, 5. 2 to 250, 4, 250 to 3, 4, 3 to 350, just 1, 350 to 4, 3, and then the 1 from 650 to 7, and then double check. It's always a good idea to double check. So you get that all ready to go, and now you're ready to take a piece of graph paper if you have it. If you don't have a piece of graph paper, it's a good idea to use a straight edge at the very least. Yeah, a straight edge would be pretty good. So let's go ahead and put our title down. Histogram of prices of homes sold recently near Green Bay. So a date, instead of the word recently, a date would be preferred. I don't have the date. I did this, I think, 2 summers ago. Let's go ahead and put our horizontal axis down then. Now when you have your horizontal axis, there's different ways to label it. Notice the 2 different ways that are labeled on these 2 graphs. So one, the 0 to 20, 20 to 25 is just labeled this way. And that's not real clear sometimes. Again, you don't know if the 20, as the reader, you don't know if the 25 quiz grade got put to the left or if the 25 quiz grade got put to the right. Same thing for 60. You don't know if the 60 quiz grade got put to the right or to the left. So that's not as clear. This way is more clear. So each bar is identified with its beginning and ending measurements. So I have no preference of how you're going to do it. You can pick which way you like. There'll be a little graph paper on your quiz. Okay, so I think I'll label 0 to 50 like this, 100, 150, 200. And again, be consistent. Don't miss any values and use a consistent size. So I'm using 1 square is 25,000, 2 squares is 50,000. Really, I'm not doing 1 square at all, really. I'm doing 2 squares, yes.
What length is that again?
Just right here? Or you mean the...
What centimeters, what length is that?
I'm not going to have I'm going to have to keep going because I don't think it's all going to fit. So however long you need to keep going. So keep making your...
Oh, I see. Okay.
Yeah, so keep extending your horizontal line as you need to. Now, you can do this on a spreadsheet with Excel. In fact, can you please bring us something you can use a spreadsheet on Wednesday? Okay, bring a laptop or something that you can use a spreadsheet on, Excel in particular. Anyway, you can do histograms on a spreadsheet. I don't really care for the ones that are automatically generated on Excel. but they might be sufficient for whatever your task is. So make your horizontal line as long as you need to fit your scale consistently with no breaks, and label it. This is thousands of dollars. Anybody remember what I said the vertical axis is always labeled? Yes, good job. Frequency. I often use a histogram to look at exam grades. It's very nice for that. On your vertical axis, don't shrink it down too much so that you can't see the variation between the numbers of houses sold. So you need enough space there to see the difference in the different amounts. Well, now I covered up my data. Let's see if I can get both on the screen. I think so. All right, so 0 to 50. Oh, no, I don't actually have the data. Here we go. 0 to 50 was 0. 50 to 100 was 4. 100 to 150, 6. 150 to 200, 5. 2 to 250, 4. 250 to 3, 4. Sometimes people actually put the number on the top too, like put a little 4 on the top of each of these and 5 and 6. If you're in the hundreds, it's nice to do that. If you have hundreds of frequency, it's nice to have that number. 3 to 350, 1. 350 to 4, 3. 'And then we have a big gap until we get to 650 to 700. So that big gap shouldn't be replaced with a break in the line. That's a distinguishing feature in your data. The whole point of the histogram is to try to make data visual, and now you can see clearly, wow, there were a lot of houses that did not, there were not any houses that sold between 400,000 and 650,000, and then there was this one expensive house. It makes it real clear that that's what happened. Does anybody have any questions? Let's go ahead and label the parts that I'll be looking at to grade you on when you do this on your quiz, so that you can make sure you have it, okay? You need the title, and, label, and the title. So I'll think of the title as the word frequency and the label as the numbers, okay? So you have the title is the thousands of dollars, and then the labels are the numbers. And you have no breaks, no change in scale. You want that scale to stay consistent because that's what you're trying to exhibit. And if you're changing your scale, that's distorting your data. And then the bars are right next to each other. Anybody have any questions? So what I wrote messy, didn't I? Which one is it hard to read some of these? Which one? Okay, then let's go.
It says no breaks or what is it?
No breaks and no change in scale. No breaks and no change in scale. Let's go ahead and try doing that for these Math 101 grades. Let's see if you can do this one, and then hopefully you'll have the hang of this pretty good, okay? So go ahead and do the histogram for the quiz grades. Let's agree on a bin together, and then ours will look similar to each other. How about your bin goes 0 to 10, 11 to 20, 21 to 30. But again, if you're doing this on your own, it's your choice how you set up those bins, whatever helps clarify the data. So see if you can go ahead and make that one on your own, and I'll come around and see how you're doing. Raise your hand if you're stuck. So if you made your bars just 1 unit wide, that's fine. Okay. What I'm going to be checking, and what you can check on your own now, is to see, do you have a title on the top? Does your vertical axis say frequency and then have numbers? Does your bottom horizontal axis say grades and have numbers as well? And are both your sets of scales consistent with no breaks, no changing in the scale? So if you made your bins a little differently, where you counted 10 to 19, 20 to 29, 30 to 39, then you're going to have a little different look to yours. Okay? And you feel free to let me know if you want me to check yours, okay? Anybody have any questions? Yes?
For the bottom axis, instead of having like 10, 20, 30, could you have 1 to 10, 12, or 11 to...
Yeah. Yeah, so if you do that 1 to 10 like that, 11 to 20, 19 to 30, whoops, 21 to 30, like that, yeah, you can do that. So either way is okay, and that's why I showed you this. I kind of like this way better, because then you don't have that weird, well, where did 20 go, or where did the 60 go? I kind of like this way better, but it's more writing, so it's up to you. Anybody have any questions? Yes?
Do we have to write that there's no breaks or anything like that?
No, don't write that there's no breaks. Just, I'll be looking at your axes for no breaks. Well, we're going to turn our attention to another way to view data, and that's a box and whisker graph. So here's a selection of several box and whisker graphs for the speed of light. And a number of experiments were done, and then those were repeated 5 times. So this represents 5 different sets of experiments, and it gathers the data. What's in the box is 50% of the measurements. So the box contains the middle 50% of the measurements. Remember, we found the median was the middle. That's what these horizontal bars in the center of the box are. And then the 50% of the measurements are in the box. The whisker goes to the maximum and down to the minimum. One of the strengths of a box and whisker graph is in comparisons, so that's why we have this example with 5. Once I tried 2 different ways of teaching a Math 101 class, and I wanted to compare how the students did. When I just looked at the averages of their final exams, they were only a point or 2 apart, so it wasn't very helpful. But when I put them in a box and whisker graph next to each other, then I could see that one method had 50% of the students in this box slid up higher than the other class. So their horizontal bars were about the same. But actually, this would be a good example. This 50% of the grades would have been pushed up like this compared to here where some were lagging behind. So box and whisker graphs can be very useful, and they're actually quite simple once you know what to do, and they help us understand the 5-number summary. So let's go ahead and take a look at how you would make a box and whisker graph. First, I want to figure out the 5-number summary with you, and I have it written down nicely, so I'd like to copy that. I don't think there could be too big a desk for me. I would still need more space. So we're still in section 9.2, but now we're looking at box and whisker graphs. So box and whisker plots or graphs. So we're going to use a 5-number summary to figure those out. The 5 numbers are the min and the max. Those are the easy ones. You just have the smallest number and the largest number. And then you have the median, which we already talked about. That's the middle number, Or if you have to, if there's two middle numbers, you average those. And then you have the first quartile and the third quartile. So quartile just means quarter. So you have the first 25% of the data, and then you have the third quartile would be 3/4 of the data. So to find the quartiles, first find the median. First find the median, then the first quartile will be the median of the smaller half of numbers that you have. So we'll look at an example of this in a minute. The first quartile will be the median of the smaller half of the values. The second quartile will be the median of the larger half of the values. So we're just finding the median, and then we're splitting, the median splits the data in half, and then we're splitting the two halves in half, finding the medians again.
Do you mean the third quartile?
Did I write the third? Oh, yeah, thank you. I do mean the third quartile. Good catch. The third quartile will be the median of the larger half of the values. The second quartile is actually the median. Okay. Well, let's do the houses first, and then we'll do the grades again. Whoa, we need a small marker. Okay. So we're going to take the houses, the prices of homes sold recently, the 5-number summary. I think I can make this a little bigger and still show these, so let's do that. Okay. Prices of homes sold recently near Green Bay, and we're going to do the 5-number summary. So you have the min and the max and the median. So the min is the smallest number, the 65,000. The max is the largest number, 669,000. The median we found in class. Remember, the median is the middle two numbers averaged, or sometimes there's just one middle number, and then you can take that. But this time we had an even number of data points. So the middle two numbers were the 15th and 16th. So there were 30 data points altogether. And when you take the 15th and 16th numbers, there's 14 numbers smaller than the 15th number, and there's 14 numbers bigger than the 16th number. So to find the median, we averaged 178,000 and 198,000. So you add them up and divide by 2, and we had 188,000 when we did that in class on Friday. So once you have the median, well, that divides your data in half. So now to find the first quartile, we want the median of the lower half of the numbers. So we're looking at the numbers that are labeled 1 through 15, and we want to find the median there. So what's the middle number out of all of those, now that they're ordered there? What's the middle number? So the 178 and the 198 are the middle of the whole thing. So that was where we calculated the median. And now we're looking at the numbers labeled 1 through 15. So from 65,000 to 178,000, and we're looking for the median there. So we're ignoring these, and we're looking for the median of these. So these are gone. What's the median of what's left?
130,000.
Good. 135,000. Okay, so that's the 8th number. There's 7 numbers above that, from labeled 1 through 7, and there's 7 other numbers labeled 8 through 15. So 135,000. Now for the 3rd quartile, we ignore the ones labeled 1 through 15 and find the median. Find the median of those labeled 16 through 30.
278.
Good job. It is 278. So the 278's right here. There's 1, 2, 3, 4, 5, 6, 7 numbers from 16 through the through 22. 1, 2, 3, 4, 5, 6, 7 numbers from 24 to 30. So 278 it is. Then it's time to put that on a piece of graph paper. Another graph. A box and whisker plot. So you need a title. You need a title, and then on the bottom you'll need a scale. The ones that I showed you were drawn vertical, but usually we'll draw these horizontally because they'll just be one. The reason they were vertical is because there was 5 of them. So we put our scale along the bottom, and your scale should be just like the one that we did of the histogram. No breaks or gaps, no change, be consistent. So I'll just draw a line, and it might not be long enough here. So 0, 50, 100, 150, 200, and so on. So put your scale in the same way that you did on the histogram. No breaks, no inconsistency, always a nice steady marching along by, in this case, 50,000s. Then title that prices in thousands. You could put prices in thousands of dollars if you wanted to clarify. Now it's time to plot the information that we've labeled. So we have this nice scale we made, and we plot the 5-number summary on it. There will be no vertical axis. No vertical axis, just the horizontal one. So first the median, 188,000. Mine have each line being 25,000. If you are using lined paper, it probably would have been better to turn it sideways. I'm sorry I didn't think to tell you that, because then you could have a better scale for yourself. So the next one, turn your paper sideways. So 188,000 is our median. So between the 175 and the 200, so that's your median. First quartile was 135,000.
How do you know where to draw that line?
So look at your scale under here,
I know the number, just like why did you draw the line where you did?
Oh, like instead of up here or down here?
Yeah.
It's a random placement.
So
So
it
just
doesn't
so
matter.
it looks neat. Yeah, it doesn't matter. You could be up a little or down a little.
And it doesn't matter how long it is?
No, it doesn't matter how long it is. I usually choose an even number of squares so I can put the whisker in the middle more easily. Okay, so thank you for clarifying. Okay, so any other questions? Okay, so you get your median in there, and then the first quartile, 135. So 125 is halfway between 100 and 150. You want to be between the 125 and the 150. Third quartile, 278, so pretty close to the 275 mark. So this box contains 50% of the data points, and you can see right away that the 25% below 50 below the median is more compact and tighter together, and these are spread out a little more. Let's go ahead and put the max and the min on. So the min was 65. So find that on your scale. And the max is 669. Okay, so remember if you're using graph paper like I am, then each little box is 25,000. So I do watch that when you hand in your homework on your quiz. And then you put a dotted whisker. So we have min, max, median, first quartile, third quartile, title, label, title. No vertical axes. There would be no meaning to a vertical axis unless you were comparing several box and whisker graphs. So I just labeled everything in green that I'll be looking for on your quiz when you take your quiz. We'll go ahead and do one of these for the grades as well now. Does anyone have any questions?
Why is it a dotted line?
You can put a solid. It's just typically a dotted line. So that's what I use, but I'm not going to take off points if you use a solid line.
Okay.
This 669 is actually an outlier. When you have one that's so much bigger, sometimes people just put a point here and put the little vertical bar at 385, the next data point, and leave this blank. If you want to do that, that's fine, but I don't think we're going to worry about outliers in our class. So let's do the 5-number summary for grades. So are there any other questions? So for the grades, we have the min, the max, and the median. The minimum's the smallest number, 28. Maximum's the largest, 99. And we figured out the median in class on Friday. We have an even number of data points, so we had to average the middle two. So we averaged the 71 and 74. When we did that, we got 72.5 for the median. So we need to find the first quartile. I don't think it's 59. Let's see. Maybe it is. So if we have 59, then there'll be 6 above it. 1, 2, 3, 4, 5, 6. Very nicely done. Yep, 59. Now we need to find the third quartile. So it's the median of these numbers that are labeled 15, 14 to 26. Did you say you had it?
85.
85? So let's see, that would leave 1, 2, 3, 4, 5, 6 numbers above and 1, 2, 3, 4, 5, 6 below. So yes, 85. We have all the data. We can go ahead and put it on the box and whisker plot. So this is a box and whisker plot for Math 101 grades. We label our scale. So nice consistent scale. We want those long whiskers to show that the quartile is all spread out if that's the case. Okay, so you don't change your scale. You've got a nice consistent scale. Median 72.5. So halfway between 70 and 75. First quartile 59, so very close to the 60. Third quartile 85. Minimum at 28. And maximum at 99. So again, this short whisker on the right means that the top 25% was clustered up to the right, whereas the long whisker on the left means that the data over here was spread out more extensively. So quick ways to view data, box and whisker graph or histograms. Please take a picture of this for your 9.2 class activity, the box and whisker graph for the grades that we just made, okay? Yes.
Last one or maybe the first one?
This one is the one that I was thinking of. If you put the other one in on accident, I'll take the other one too. Just so it's a box and whisker graph that you made.
I mean, the first box was the graph from the housing.
Oh, that was a histogram? Wait,
So we did two histograms.
yeah. So the ones for, if you put both in, that's fine, but this is the one I'm looking for.
The one for grades.
The one for the grades is the one that I'm looking for. Yeah.
So just put the housing one in, that would be sufficient.
That'd be fine. I'm not, if you have a box and whisker graph and you put the wrong one in, it's I'm not gonna.
Okay, all right.
Any other questions?